Google just open sourced another AI agent called MLE-STAR that act like your ML engineer. That means this AI agent will train custom machine learning models for you from scratch using your own training data. And as they noted in the paper, they were able to actually win Kaggle competitions and win medals by this agentic solution as they tested that on multiple Kaggle competitions. So I couldn't stop myself to give it a try. As you can see right now here, I'm using Google ADK to test their open source AI agent to see if I can win a given Kaggle competition. So in this video, I'm going to show you how you can implement this solution on your own environment, and then check this out if you can utilize this for training your own machine learning models, but without you doing anything. Let's check it out. Alright, let's get into MLE-STAR, which stands for Machine Learning Engineer, that is based on search and targeted refinement. This is the name and approach that Google just proposed in the paper published, and they also open source a solution so we could check, and that's how we're gonna do to get hands-on on this solution. Well, first, let's check it out. What is the main contribution of this solution and why this is extremely impressive? As they noted in the paper, they were actually benchmarking their solution on Kaggle competitions to see if this AI agent can act like an expert data scientist or ML engineer to come up with winning solutions to those competitions that are released by Kaggle. And they noted in, I think, around 22 Kaggle competitions that they use as a benchmark, they were able to increase that win rate to 64% of winning medals in Kaggle competitions by different models like Gemini 2.5 or Gemini Flash. And we will see the details shortly, but this impressive results is a good sign that as of now, we can potentially go forward fully automated machine learning engineering. So moving further, what they are trying to tackle right now, we call them as a challenge, is right now a lot of our typical machine learning or data science workloads are just repetitive tasks on querying the data or doing feature engineering. So up to around, on average, 80% of our time is really dedicated to coming up with the proper strategy of a pipeline on how to tackle and massage the data to make it ready for an algorithm to train our machine learning models. And obviously, choosing what's going to be the best machine learning model or models is another challenge and nightmare by itself. So with the announcements of all these language models that we can generate codes and generate some solutions by them, obviously that was a good shot. But the challenge is all these language models are trained up to a level of data in the past. So their knowledge is biased towards choosing algorithms and codes that they have seen in their training data. That means you don't necessarily get the state-of-the-art model proposed or the code proposed by language models in a shot to use that to train a machine learning model with your own data. And obviously, there are some agentic solutions being in place that they use language models, but most of them, they literally just change entire data code and code structure to come up with the best solution and refine that and then propose another algorithm or another code to train your machine learning model. So with having this challenge in place, MLE-STAR's proposed an innovative approach. Instead of really just focusing on language model knowledge by itself to give you an answer or give you a code that, hey, this is how you train a machine model or act like an ML engineer, they are enabling the solution initially by web search. So what happens is this agentic solution first go to the live public data to see what are the state-of-the-art models or algorithms are in place that are suitable for your machine learning project. Then it will propose that and use it to train and develop a code to train your machine learning model. So this is not just the end of the story. This is actually the beginning. So with that initial search that we do through web, then those agents will start to have targeted refinement. So what does targeted refinement mean? We have different components of machine learning blocks. Let's say we have feature engineering, data cleaning, further featureization, like let's say dropping features or adding more features and then choosing the best algorithm. So these are different code blocks that we usually develop for training a machine learning model. Now, what this approach does, it considers those code blocks separately for refining them, proposing a new code block or new step, and then changing end-to-end approach. So instead of suddenly restructuring all the code and all the steps, it make it modularized and then focus on each modules to refine them and iteratively make them better. And this really what made its solution to be much more impressive compared to previous results that they have benchmarked in the paper. And ablation studies, which means they go back to all these code blocks to see which step of this ML engineering solution that we have initialized works is more impactful. For example, does feature engineering is the most impactful step within this end-to-end solution, or the choose of the algorithm or the hyperparameter tuning we have on that algorithm is the most impactful one as we change it to see the results. So based on the most impactful analysis on code blocks, it goes back to make it better because it knows if I change that step, it will impact the most because that's the most influential step within that end-to-end process, which is called ablation studies. That is implemented by some ablation agents within this solution. All right, let's check out their papers. And in the paper, they have actually great architecture that talks about this end-to-end process that in high level I just mentioned to you. So at the beginning, they have 3 phases by MLE agent to start training a machine learning model for you. First, we have this step A, that is initialization. What happens here is that, as I told you, MLE-STAR, which is the name of this agent, goes to live public data, internet, to find, based on the task that we're giving to this agent, hey, I want to train a machine learning model for this and that based on this data that I have. This is the task. And we are going to give it to this AI agent as I'm going to show you in the demo shortly. After having that in place, then it goes to the web to search what are the best algorithms that are suitable for this solution. Then it might come up, let's say, with 2 candidates. Then it will start retrieving those information, generating codes for using those algorithms, then training the model, and then evaluating that. After evaluation, now we have this score that ranks which one worked the best. Then we have 2 candidates. We iteratively check them which one is better to propose them potentially as our winning algorithm for now. Then we have this initial solution just selected. But this is just the beginning. Phase 2 is targeted code block extraction. Now I want to see, based on this initial solution that I have, I'm going to ask this critical question from this agent that which code block, which step of my ML pipeline that you have proposed is the most impactful one. As we just change it, it will significantly change the final outcome or performance of the solution. Then we selecting that using this ablation study that this agent does, then we're seeing that, okay, removing features is the one that gives me the most impactful results, or imputation, or doing literally nothing, just keeping the original as is. Then with having that, let's say imputation is the one that impacts the most, I'm going to see if I can refine that imputation to make it better as it is impactful. This is what we are doing with this targeted code block extraction and refinement. Well, with having that code block selected, then I will go with the refinement section. So I will propose multiple plans on how I can refine that code block and replace it if I get a better result. So with doing this iteratively in an outer loop, we have this improved solution, and we can go back to this inner loop again to see what other code blocks are impactful to do it again and refine them better. This is literally in high level the approach of this MLE-STAR. Now let me show you what are the sub-agents that they're using for developing this solution. Alright, as you can see, there are a lot of different agents, but let's make it simplified. The MLE-STAR, which is the master agent, will have access to these sub-agents. First, we have this initialization agent. If you follow my pointer, this is the one that actually does web search to see what are the algorithms right there in the live public data, which one is most applicable one for this scenario. So this one has access to some tools that, for example, it checks the model, retrieve the model from public web. It has some debugging actually agent that debug if the code of that algorithm is not working well. So you don't need to manually debug anything or running any codes. It is all end-to-end automated for you. Then it also uses if the data is fully utilized in that training code, because sometimes these language models tend to generate a code that doesn't fully leverage the training data. This is what they check with an agent. Then we have this refinement agent, which this one is the one actually goes to do, that is tasked to do ablation studies to see which code block is the most impactful one in your end-to-end process to keep it better by using the sub-agents. And of course, we have debug agent as well here. Ensemble agent. Usually you might have seen in Kaggle competitions, the winning solution are the ones that they just don't use one specific model. Maybe they use tens of different models and they ensemble them together to have the winning solution. And this is what this also agent do? This actually will try to see if, let's say, from tens of different machine learning models that this agent has trained for you, how can I ensemble them together to give you a final answer or final solution? Maybe ensembling two of them, three of them, or no ensembling. And then ensembling has different approaches. Which ensembling approach works the best? That's another critical thing that this AI agent will decide to implement. And lastly, we have submission agent. This is just for Kaggle, because when you submit your result to Kaggle, they give you a test data set and they are asking you, give us your model predictions, and we're going to let you know how good or bad you are. So that submission is a CSV file of your machine learning model predictions that you have trained. And this is what this agent really does. So this is really optional if you don't want to use the solution for Kaggle. You want to use it just for training machine learning models for your use cases using your own data. As they noted in the paper, they utilized 22 Kaggle competitions. This is the benchmark Kaggle competitions that some other similar solutions they have used in their own papers. The best alternative example before releasing this paper was a solution called AIDE, and they were showing in the paper that with this approach, they increased the winning rate of those Kaggle competitions from 25 medal achievement rate to 63, which is a significant difference. And of course, like just having an AI agent without any potential human interval in place, just having your prompt and task description to come up with a winning solution on Kaggle competitions, which some of them are pretty challenging, is truly impressive. And to just let you know why they came up with this approach, I told you because of that web search, it was truly a game changer as one component. Here are some examples. Without actually having web search, just if you go ahead and ask a traditional LLM or language model for training, for coding for you to train, let's say, image classification, there's a great chance that it will propose an approach using, let's say, with ResNet. But this is released on around 2015. With this MLE-STAR that do initialization with web search, it proposes you solutions like EfficientNet, VIT. These are much more recent algorithms and definitely impactful as well, as they showed plus 37 ML rate winning just with having that web search and having a better choice by that agent. Same thing for text classification. Language models are tend to just use logistic regression, but having MLE-STAR, I was seeing that it is using models like transformers proposed to train a machine learning model for me. And same thing for tabular data. And last few things before I go to the demo, they also propose a smart ensemble strategy that MLE-STAR is doing. So instead of just simply letting this AI agent train machine learning models, and then the final solution is a voting ensemble that vote which model works the best, they're actually merging these trained machine learning models in a much more advanced ensembling approach. What is that ensembling approach? The AI agent will decide which one works the best. For example, it can be stacking with meta learners or dynamic weight assignment or weighted averaging, recruit search optimization. These are different examples of ensembling, and there are much more. And this is, again, another factor that shows MLE-STAR goes beyond just one shot of training a machine learning model and just simply ensembling them by voting. It's worthwhile also highlight that they check data leakage. They have an agent inside MLE-STAR or sub-agent that checks if there's a data leakage in your solution or not, because a lot of times when we train a machine learning model by accident, we might suddenly use a portion of a data in test data set that the model has seen in training data. So we'll get surprised with great results in testing the model, but model is cheating because model has seen those models. So this is already checked by the solution. Data usage checker, I told it gonna check if the code generated by language model is fully and properly leveraging the sources of data for training the model. And of course, we have the debug agent. There might be codes that generated by LLM and they have bugs and issues. So you don't need to refine them or check them and fix them, as it is all managed by this solution. All right, so let's see how you can get access to this. They have open sourced all the codes as they develop this AI agent using a Python library open source released by Google called Google ADK or Google Agent Development Kit. Google ADK is just an open source package similar to other agentic frameworks like LangChain, Llama Index. These are frameworks that let you create AI agents in an abstracted manner. If you don't know what is Google ADK, it's extremely powerful, open source, released by Google. I have created a dedicated video about Google ADK. I will add it to the top right of the screen. Check that out. So not going through the details of that, but they use it as a mean to develop this AI agent, and I'm going to show you how you can use it. So I will add the link of their source code in Discord channel, and the link of the Discord channel is in video description below. Go there. There's a section called reference section in a sub channel of the channel. If you go there, you will get the link accessing to all the codes of the videos that I have been developing, namely this one. So here, when you come to this GitHub repo, the very first thing you need to do is pip install Poetry. They are using Poetry to manage dependencies and installing packages needed for running this AI agent. So after having that in place, only thing you need to do is cloning actually these 80K samples that has lots of different agents created by Google 80K. One of them is this machine learning agent called MLE-STAR. With actually having that clone, you just need to go to the directory of the 80K samples, agents, and this is actually the example that we're going to use. If you see left of my screen, there are multiple different agents. You can use them. They're all open source by Google 80K, but this is the one that we're going to utilize today. And then with having that path directed in your terminal, you just need to install the dependencies with Poetry install, and then Poetry environment activate will create the virtual environment that you need for running this AI agent. Something I want to note is obviously with Google 80K, you can use any language model to utilize in creating your AI agent. Here I'm going to use Gemini. That's why I want to make sure that I have these credentials added in my terminal. So if you're using Vertex AI Studio to access Gemini, set it to true. And of course, your project ID for your GCP on cloud and its location of that. Let's say mine is US Central. And what's going to be the language model you're going to choose? Here, again, I use Gemini 2.5 Pro. And if you want to deploy this solution as an API in your Google Cloud environment, you need to provide a Google Storage Bucket, because Agent Engine, which is a containerized instance that we deploy our agents on GCP, needs a Google Storage Bucket to deploy your AI agent. So this is optional. If you don't want to deploy and just want to test it locally, I also ignore this part. And then to make sure that you can authenticate to Vertex AI to call Gemini, you need to make sure you run this command to authenticate to your GCP. Again, these all just for when you want to use GCP, Vertex AI, and Gemini. And you can check the source code. You can also switch it to non-Gemini models, as they also tested non-Google models in the white paper as well. The Kaggle competition that I'm going to test to see how this MLE-STAR agent will work is predicting a biological response. This is an outdated Kaggle competition, and my goal was not really winning the prize. Just wanted to see how far I will be based on the results of the winner who got the first gold medal here. So this solution is actually a classification to predict whether a biological response from a given molecules will happen or not, based on its chemical properties, so 0 or 1. And the evaluation approach they're talking here is log loss. So this is going to check the differences of probability of having an action or no reaction based on if action happened or not. And the differences of that will give us the evaluation results. Obviously, the lower will be better. And then when I'm done, this MLE-STAR will give me a submission CSV file, which is my model predictions, that I can come here to submit them. So let's run it. All right, here's my development environment. And as I showed you, I cloned that 80K samples that include this MLE-STAR agent in my environment using the command lines that I showed you. And here you can see I have this machine learning engineering agent under 80K samples. And if I click on sub agents, these are the list of those master agents that I walk through them on that picture of the architecture of the solution. But if you're curious to know what prompts these AI agents are using and Google has set, just click on any of them. Let's say this is the one that defines how to ensemble winning models together. And click on the prompt.py. You will here see what is the prompt that they use for planning on how do we assemble these models. Or another one, if I go to that initialization, this is the one that actually search web to come up with some good algorithms, up-to-date, state-of-the-art solutions for the given machine learning task. This is actually the one that uses it. You can see that, hey, you are this is the task description that you are summarizing this task that we can use it for searching effective model for a given task type. So we use it to generate a query to go to the web data. These are, again, these just sub agents that master agent used to call, and each of them, they have different tools for debugging or checking data leakage that we discussed about them already. Now, the main part that you need to define what going to be the machine learning task that this agent should do is under this task subfolder. So when you actually download it, it comes with California housing as a prediction, as a use case task example. So feel free to change it. And if you want to change, you have three things. First, the task description. You have to just type in natural language, what is your task? For example, mine is that Kaggle competition that I just showed you. Predicting the probability that each molecule elicits a biological response, yes or no. Activity mean yes, 1, otherwise 0. Then submission format. This is the CSV file format that we need to upload on Kaggle. What is my training.csv schema and test? Just a couple of examples and what's going to be the metric that Kaggle going to evaluate, which is our main metric to evaluate the solution. And Kaggle is just an example. This can be your business metric for your use company or business or project machine learning. Then having that task described in text, you need to just upload your test and train CSV. I got them from Kaggle. For you, it can come from your company database. You can connect it actually to database without even exporting if you want, or any sort of machine learning data that you have to train your custom machine learning model by this AI agent. With having that all done and all defined, what you just need to do, we just simply type in port 3180K web. After following the command lines that I showed you, this will launch Google ADK UI that you can chat with this AI agent. So I just hit enter. You can see that it is actually launching a local UI for me. If I click on select agent, machine learning agent, let me just type hi to see if the agent is working. And again, I'm using Gemini 2.5 Pro connected to my Vertex AI to enable this AI agent. Seems like it is responding. So let me ask that, what is your tasks? What is your task? Now I'm expecting that it tells me that task description I set in that text file that there you go, predicting a biological response, and it seems like it knows and ready to go to execute it. So I just type execute your task. So this will start calling that initialization agent to go to the public web to see what are the state-of-the-art algorithms that are suitable for this machine learning task, which is a classification based on the training data that I have and the metric that I have to assess the solution. All right, you can see that now it is transferring my ask, which is executing the task, to different agents, starting with the initialization agent. That one went through internet with this public URL citations that how it got the these answers from, and it's proposing that, hey, LightGBM, XGBoost are good to start, and then potentially having that as sources of algorithm choices to start maybe trying to create my training code that uses these algorithms. Again, these are the initial choices. That doesn't mean these are going to be my winning solutions. And then there you go. This is the one that actually generate the code to train my machine learning model and then create that submission CSV, which is the one that I can later on upload it to Kaggle. Now it can iteratively call for a while as I wait, and if you potentially wait longer, it will keep refining the solution and potentially giving you better and better solutions. So I have already done a longer one to save the time here. So let me switch back to the one that I ran for a while to show you its results. All right, after running it for a while, you can see that right now you have much more components of different training codes, improved version of those training codes, and then some ablation studies that check which block of code is the most impactful one to refine my training codes. And then for iteration number 2, I have the same thing. So it is iteratively checking which one is the best one to keep refining them. And I have a JSON file called final state. This one is actually like a memory for the agent and also summarization for me either to see all different steps that this solution is utilizing them so far to giving me, hey, I am doing now this final validation. I went through importing these packages, also making these changes or changing the algorithm. And here's my score so far. If I just control F on a score, you will see that almost 22 times. Initially, its scores wasn't that good. It started with 0.6. But as it was keep refining it, you can see that gradually the scores are getting better. There are some fluctuations, but so far I would say on average 0.44 or 43 is the one that's actually giving me the best results. And if you're curious to see what happens inside Google ADK UI, I have actually this summary that shows sort of, again, what's happening with all iterations if I'm gonna scroll down, honestly, the information amount is huge here, but I just want to show you how it is searching web to come up with the proposed solution, then training my machine learning model using some codes it's providing. I had some issues in the code, some bugs, some packages that are not installed, and then after fixing that all by itself, it is telling me a summary of so far what I have done. I have used this model with this strategy of splitting for training and validation, and here's the final results. After giving me the summary, now it goes to application studies to see what it can do better. You can see that this is a issue example that it couldn't find a package. It went ahead to make sure that it can install that by fixing the code all the way going down, and honestly still keep going and going. So I could run it even more to come up with better models and better solutions, but the approach and goal here was just checking out how it works and demoing its capability. So I paused for a while, and then as you can see, I have my submission CSV that is ready, that I can upload it on Kaggle to see if I can win. Now, getting back to my Kaggle, which here it is. If I go to late submissions, because obviously this is a pretty outdated competition and I just wanted to give it a shot to see if I can be among the winners, you can just click on browse and upload that submission CSV that I just showed you. As I already did and showing the results, I was just keep uploading the submissions that this solution was generating to see what's going to be the score. So when I was uploading that, I would say the best one is submission number 5. This is the one that has the lowest number, which is the lower the better for that metric that we have. And if you're wondering how far I am from the winners, I go to the leaderboard. The first person that got the gold medal was 0.37. Mine is around 0.4. Obviously, I have room to grow. You can see there are a lot of people, they actually got the scores less than 0.4. So it shows that right now, if I go all the way down, there you go, here around, maybe the person is starting from 200, the rank 200, people are better than me. So I'm among the first, I would say 200 compared to, I think around 600 people that they participated in this competition. So for me, just waiting for 15 to 30 minutes, letting this agentic solution come up with this, with a winning machine learning model that is rank amongst first 200 people. Although it's not impressive so far, but it is pretty optimistic that if I could let it run longer, I would certainly achieve better results without really my intervention on doing anything, coding anything, or debugging anything, which is absolutely amazing. Alright, that was all this video about MLE-STAR. I hope you found it helpful. If yes, I would be very thankful if you click on like icon. And make sure you share your thoughts, questions, and comments in the comment section below, and subscribe so you don't miss the next video. Thank you so much.